Hello guys, here Mr. G with another video for the grade 11s about stoichiometric. Now this question is quite important for the grade 11 but also applicable for grade 12 and grade 10. The question said brown nitrogen dioxide is produced according to the reaction, and there you have a quite long reaction between copper and nitric acid. It takes 200 milliliters of concentrated nitric acid to react with all the copper. Now all the copper is being used, so it means guys that the copper is going to be the limiting reagent. So all the copper was used at the end of the reaction, and only 200 milliliters of nitric acid was used. Therefore the nitric acid is the excess reactant or reagent. It doesn't really matter the word you use there. So this one is the very important starting point here. Right? If the concentration of the acid is 3,13 mole per cubic decimeter, determine the mass of copper reacted. So in the first question they want to know how much of this one was used, which is obvious, everything, and then they want to know the volume of the gas produced at STP. If you go to the equation, the only gas you have is nitrogen dioxide, and they want to know what is the volume of the nitrogen dioxide at STP. So the question is quite simple. It's the same thing we have been doing up until now, okay? So the first we're going to calculate the number of mole of the nitric acid. Why the nitric acid? Because there is the data we know. We don't have any other data. We know that 200 milliliter was used. It means there is some left over, but in this question they don't ask anything about that, and the concentration is 3,15. So the step one of what we are going to do first is to calculate the number of mole of the nitric acid. So what we have here, we have the volume of the nitric acid is 200 milliliters. We cannot work in milliliters. Now remember that 1 milliliter is equivalent to 1 cubic centimeter. All right, it's the same one, and you have to convert. How do you convert? Quite simple. To convert from cubic centimeter to cubic decimeters, you are going to divide by 1,000. All right, and this one is 0,2 cubic decimeters. There we are. Now what else we know? We have the concentration is equal to 3,15 mole per cubic decimeter. That is given to you, and we are looking for the number of mole. You always want to calculate the number of mole first, because with the number of mole you can use the ratio. So what formula can help us here, guys? Concentration is equal to number of mole divided by volume. I like to write the formula as it is in the formulas given to you in the exams, and I also like to substitute in this specific order. Why that? Because if you make a mistake rearranging the formula, you will lose the marks. However, here for instance, let me show you, you'll get 1 mark for the formula and 1 mark for the substitution. But if you rearrange and you make a mistake, then you lose the mark of the substitution. That is why I don't like to rearrange the formula first. Anyways, when you do this one, you get that the number of mole is going to be equal to 0,63 mole. Now guys, what we are going to do with that one? Simple. We are going to come here and we are going to use the ratio. We are going to use the ratio of everything. First to find the copper, and then to find the nitrogen dioxide. Okay, so first for the copper we are coming here and we are going to write ratio of copper to the nitric acid. The ratio, if you go to the equation, is going to be 3. If you see here, is 3:4. It's a funny ratio here. That is why I said use always the cross product. 3:4. How much of the nitric acid we have here? This 0,63. So if you have here 0,63 0.63 mole, how much of the copper will you have? And here you do cross product there. When you do this cross product, you'll get 4x is equal to 3 times 0.63, right? So you get that 4x, I'm doing it step by step, 1.89, and then x is going to be equal to 1.89 divided by 4. And let me see, calculate, I get 0.47 here. I get that x, or number of mole of copper, is equal to 0.4725. I am not going to round off because it's not the final answer. So now with this one, we are going to calculate the mass of copper, which is the first question. We now know the number of mole of copper, therefore we are going to calculate the mass. This is for copper. This is for copper. So to calculate the mass of copper, number of mole is equal to mass divided by molar mass. Same story, I do not like to rearrange. I substitute in here. Number of mole is 0.4725 equal to mass. The molar mass for copper is 63.5. And when you calculate here, you will get number of mole for mass is equal to 30 grams. That is the amount of copper that was used during this reaction. I'm going to write grams of copper. Cu. That is the answer of the first question. Now for the second question, it's quite simple because we already have the number of mole. They say how much volume of gas is produced, which is the nitrogen dioxide. That is the only gas being produced here, guys. So all we're going to do is to use the ratio. Now we can use any ratio because we know how much copper was used, we know how much nitric acid was used. Let's use the nitric acid, which is the first one we calculate here. Let's go to a new page and we are going to say how here now, ratio of nitric acid HNO3, because it's the one we calculate first, but it doesn't really matter, to the nitrogen dioxide NO2. We go back to the reaction. We're using the nitric acid, which is 4, nitrogen dioxide is 2. Nitrogen dioxide is 2, so it is 4 is to 2, or we can say 2 is to 1, is the same thing. Now let me make something clear here, because I always say you use the limiting reagent to calculate the number of mole of any other substance. Guys, we're using the excess reagent, but we are not using the whole amount. We are going to use the amount that was actually used out of all. All right, so this 200 is what it was used, so that is why I'm using the excess reagent. It doesn't really matter because I don't know, I'm not using the total amount. 200 is not the total. The 200 is the amount that was used. They still left over, but we don't know that amount and we don't actually need it. Okay, so we're going back here, and then the nitric acid, the number of mole of nitric acid was 0.63 mole. How much of the nitrogen dioxide is needed or is actually produced? Cross product, you get that 2x is equal to 0.63. The number of mole is equal to 0.63 divided by 2. The number of mole is equal to 0.315 mole. That is the number of mole of the nitrogen dioxide that was produced. So now we're looking for the volume at STP. Number of mole Number of mole is equal to volume divided by molar volume. Same story. I am going to substitute as it is in here. So it's 0,315 is equal to volume. Molar volume at STP is 22,4, and then the volume is equal to 0,315 multiplied by 22,4. The volume is going to be equal to 7,056 cubic decimeter. Guys, this is the end of the question. I hope it helps. It's also a good question because it's a little bit different from what we've been doing. But thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.